Hello everyone. Today we're going to start a new case study on DDoS attack. This one is on a 300 gig DDoS attack, happened in 2012. Some standard disclaimers. The company involved in the cyber breach hasn't publicly released all the detail of the incidents and probably will not do so, but enough information exists online and within the cybersecurity community to piece together what likely to happen during the data breach. Although care has been taken care to ensure accuracy of the information provided, the presenter assumed no responsibility. Therefore, the presenter also assumed no responsibility for the consequence of using such information. So again, this case study was adapted from a presentation by Matthew Prince in Black Hat Conference 2013. And it was on a 300 gig DDoS attack, happened in 2012. And information was taken from public source and modified for education purpose. And you can actually take a look at the presentation from the link below. So this is more detailed information about that presentation. Just give you a little bit of background. And the Black Hat Conference is one of the top cybersecurity conference, and every August is in Las Vegas, and the conference fee is over $2,000, so it's a quite expensive conference, but it's worth it. Okay, and they have a lot of research presentations, training workshop, and meeting hackers and the white hat and everything from people around the world. So they also have Black Hat Conference in many different places, like in Asia, in Europe. So just kind of like a little bit background about the DDoS attack. So the goal of denial of service attack is to make the service unavailable. That's why it's called a denial of service. The way it's just overloading. Okay, it can overload the server, router, network link. You target at a bandwidth, you target at a system resources, or you target at application resources. The distributed DDoS attack is basically you are using multiple systems to launch attack from multiple sources that result in higher traffic volume. That's called the distributed denial of service attack. And usually there's a lot of compromised PC or workstations because you have to launch from multiple places. Okay, and usually people install some malware and make those machines become zombies with a backdoor program installed, form a botnet. Actually, people will be able to purchase some of the botnets on the black market, the nodes. So this case study basically just briefly explain what happens in this DDoS attack. On March 18 to 21st, 2012, there are anonymous DDoS attack target at the company called Spam Horse. And at that time, it's about 0 to 80 gig attacking traffic. And a few days later, the attack peaked at 300 gig BPS. So a little bit information about the victim. It's called Spam Horse, which is an international non-profit organization which mission to track the internet spams operation and resources. I guess most people probably never heard of this company, which is normal, and that's why as a middle-sized organization, they don't really have enough resources to defeat this type of 300 gig DDoS attack. So one of the questions we want to discuss is why 100 gig BPS become the magic ceiling in some of those DDoS attacks, especially in old days. One of the main reasons is because back several years ago, many routers, their hardware limits, it's 100 gig. Okay, so even if you want to launch attack with larger volume, but the router just limits the attacking traffic. Now, of course, things change a lot with the update with the new routers, with the new servers, new band, everything. So, but that also make DDoS attack, the attacking traffic, the peak traffic, way above 100 gig. So just give you some idea exactly how much is the 300 gig attack. So here I'm using Google search. On average, Google process like 40,000 search per second. And average page size, we assume it's 300 kilobytes. Just can you calculate the average Google search traffic per second in BPS and compare the result with 300 gig. Now, I'm not sure if you know how to do the calculation here, but give you some hints here. 1 byte is 8 bits. Remember, the web page is in byte, but the traffic is in bits. So KB is kilobytes, GB is gigabits. Okay, so it's 1,000, so 1 gig to meg to kilobyte. Okay, so here we do the rough calculation. On average, Google process like 40,000 searches per second. Okay, so that's the average page size is 300 kilobytes, which is just like 2400 kilobits. So we convert this to bits. So the average Google traffic worldwide per second, you multiply these two numbers together. Okay, this is the first number, this is the second number, and you want to just combine this together, and you convert this to gigabit. Okay, because right now it's kilobits. They transfer to meg, then transfer to gig. So that's why you get roughly about 100 gigabits per second. So now you have an idea of how much is 300 gig. It's basically the Google query traffic worldwide. It's about 100 gig. Remember how large the company is, Google, and they have millions of servers worldwide to serve those traffic. Now, if you have 3 times of that traffic targeting at a middle-sized company, and you can easily crash that company's web server. So now the question is, how did a hacker amplify the attacking traffic by misuse OpenDNS resolver? Okay, so in this attack, the hacker utilized something called a DNS amplification attack. Basically, they send a small amount of DNS requests, and they get a very lengthy amplified DNS response. And they are using something called a no TCP. Basically, they want to use UDP requests. Okay, you think about why? It's because you need to hacker need to fake the IP address. There are a lot of open DNS resolvers, like 28 million of public DNS server worldwide, which is the normal thing because people actually using those DNS server. The DNS server are not supposed to be kept secret. It's supposed to be used by public. But hackers can also misuse those public DNS servers. And the other key technique in this attack is IP spoofing. So how do you actually create a spoofed package? Okay, there are many different ways. Like you can write some kind of Python script. You'll be able to just spoof a package. It's really simple. Okay, you can use a scripty module. You'll be able to do that. Or if you are familiar with IP tables, there's a technique called IP table masquerading. Okay, that's essentially changing the IP address. You can view they are doing a spoofed IP in good way. Or if you are good with C-socket programming, you can just write C code to launch a package with spoofed IP. Or there's a lot of third-party tools which you can just send out spoofed IP. Okay, so how to make a package? So let's spend some time talking about the IP spoofing. If you can go to the lab 7 in this course, there is a lab on package spoofing. Okay, so if you go to the lab 7, the first part is password cracking, which we don't talk about here. But if you take a look at the section 3, package spoofing with Python, okay, you just set up a Python environment, then you will be able to just launch a fake traffic. Okay, for example, this is one of the Python scripts which allows you to actually send a spoofed package. You are using a scripty module like the IP layer, source address, destination address. Here we create ICMP traffic, and you'll be able to actually capture that traffic. You see you creating a fake traffic. Okay, you will also be able to launch a DDoS attack. For example, this is actually an example how you will be able to launch the DDoS attack. Okay, you specify the IP address, you create the package with IP layer, with DNS layer. Okay, you specify you want to query the google.com, that's the query, you merge them together, you get a package. Then SR loop here is the function where allows you to continuously sending the spoofed package. So you send the package with an interval of 1 second. You want to turn the verbose mode and the count is 5. Just send out a 5 package because we don't really want to launch the real attack. So this is just a very simple lab. You will be able to just simulate this type of DDoS attack. Okay, so especially with the IP spoofing. So the next question is, once you create a spoofed package, how do you make that routable on the internet? Now this is actually a little bit tricky question. Basically, we know if a lot of network doesn't allow spoofed IP address. So if you are inside those network, they will basically just drop your package. Okay. However, there are still a number of network which allow spoofed IP address. So basically, they just don't track whether this package is spoofed or not. They just blindly route it. Okay. So when there's an incoming traffic, they just blindly route it to whatever destination. Now, once you get on the internet, then nobody really track where you come from. Everybody just route their traffic until you reach the destination. Okay, so the key part is really you need to find some network which allows spoofed IP. Once you get on the core internet, nobody track the source IP. Okay, so good network doesn't allow package originate from IPs they don't own. However, many of them still just fail to follow this best practice. And based on some statistical result, there's more than 20% of the network. Why? Either because these are legacy network, or people don't want to change it, or just incapable, they don't know how to do this. They just didn't follow this best practice. So some of the challenge of really doing the IP spoofing, you need to find a network which allowing IP spoofing. You need to hack into those networks using botnets or zombies or purchase from black market. Then you start launching DDoS attack at the same time using those zombie machines. And this, of course, require you to carefully craft the plan and with careful execution. So this diagram shows you the reflective DDoS attack with traffic amplification. So here it's attacker. His IP is 1111. Then here are some of the legitimate servers. Okay, some DNS servers. So they send some DNS request. Usually those requests, like you send a dig request, usually pretty short, like 60 bytes. Okay, you forge the source IP address. Instead of 1111, you use 2222. So once those DNS server got the requests, they try to reply back. And their reply traffic is usually much longer. It's like 3,000 bytes, for example, because it contains a lot more information, like what are the DNS server, blah, 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 all different information. And because you use a forged IP, so they will just reply back to that forged IP, which is 2222. And here it's just be your victim network. So here, hackers send some legitimate, forged DNS request. Those legitimate DNS server reply back with amplified traffic. Okay, if the hacker can recruit enough attacking machines, they can easily crash the victim network. Okay, so this is basically how the reflective DDoS attack looks like. Okay, and why it's called reflective, you see this, the DNS central, it's just like a mirror on both sides, so that's why it's called reflective. And it's misusing DNS and misusing the traffic amplification. So as you can see in this process here, you have two key components. One is forged IP. The other is traffic amplification. Okay, if you think about even broader, you don't have to use DNS. You can use many other things like time server. A lot of times we use time server just to sync our clock, but that could also be misused. Okay, and another thing you want to notice here is because this is just like one-way traffic, so you are best to use DNS UDP attack. TCP won't work in this scenario. Okay, the reason is very simple. You never get the package back. You never get the response back. So you have to use UDP. Okay, that's the reason why here a lot of this traffic are just UDP traffic. Okay, that actually sometimes makes things easier to detect your traffic, especially when you see a large amount of UDP traffic, you can just stop it. So talk a little bit about the defense here. Okay, how do you defeat this type of attack? Of course, the most common way is cache server. You want to use some cache server or mirror servers. Okay, and one of the well-known companies is called Akamai. Akamai is actually a company providing thousands of cache servers. Okay, think about this. Every company, they need a cache server, but with Akamai, you don't have to build your own cache server. You can just rent, sign a service contract with Akamai. Akamai will allow you to use their cache server. Okay. Another question is Anycast. Anycast is a very similar concept, just like Unicast, or basically you can just reroute the traffic to any place. That's called Anycast. Akamai, how would you use Akamai? I already explained a little bit. Okay, it's very commonly used nowadays. Another defense technique is called IP traceback. So basically you want to trace back where the router, where the hacker come from. So you can do package marking or path identification. So basically the routers mark some of the bits of the receiving package to create identification of that package. Some drawback, there can be complicated, and faraway attackers cannot be detected, and also require cooperation from other routers, which they will be very reluctant to do so. The third one is packet filtering and rate limiting. Okay, we usually have ingress attack outgoing or ingress incoming traffic. Basically what you want to do is to filter out some attacking traffic or malicious traffic, or just limit the amount of traffic that can come in. Okay, how did you do this in this scenario here? If you understand what we talk about, you notice all those traffic are UDP traffic. So if you see a large amount of UDP DNS traffic, okay, the best thing you can do is just block it. To make things even better, you should work with your upstream ISP and start blocking at ISP level. Okay. So this is basically how you can defeat that traffic. How we can help each other. So if you are running open DNS resolvers, you need to keep a very close eye on those DNS resolvers. Make sure nobody misuse them, especially if you start sending out large amount of traffic to a target. Also, if your network allow IP spoofing, you'd better reconfigure your routers. Okay, we help each other. Okay, especially you just like cooperate. If you get a request from some other network, other companies, just try your best to help them. Keep an eye on the IT security news. Okay, here are some facts about the DDoS attack. So the DDoS attack are usually very short. Usually they are less than 10 minutes or 30 minutes. Okay, and the TCP was very popular. It's just because it's commonly used. But nowadays, more and more UDP attack. As I explained, it's much easier to launch large amount of attack using UDP. So the other thing you want to notice is like the peak of DDoS attack. It's in 2000 and 2010. It's about 10 years ago. Okay, if you don't believe me, you can just take a look at this source here with historical source. Okay, so you don't really see a lot of DDoS attack making headline news. Why is that? Okay, there are many different reasons behind this. If you take a look at this historical data, which I won't show it here, okay, I can give you some explanation, just my explanation. So the first thing is we are actually getting much better at defeating against DDoS attack. Okay. The second thing is motivation. So the DDoS attack, the hacker does not really gain much from DDoS attack. Okay, they gain some fame, but that's probably it. There are more exciting and more profitable battlefields somewhere else, which is similar to the Target or Anthem attack. So that's why Target and Anthem become the new battlefields. Okay, but there are still hackers doing DDoS attack. For example, in the black market, you find people who actually sell DDoS services. You can just subscribe to their services, put the target, and they will launch DDoS attack for you. Okay, so it's still an issue, but again, we are getting much better now. So some discussion question for everyone. Summarize the effective ways to launch DDoS attack and effective ways to defeat DDoS attack. Okay, some reference materials I listed here. You can take a look. And that's the end of this case study. Thanks.